Go ahead and start, guys. I do have a couple of. Oh, come on, my email. Let me get my email out of the way. Okay, close window. Okay, great. Okay, so we have metallic, non-metallic boxes. We're going to highlight what counts and what not counts. The idea is when you use it as a J box, how many conductors we can bring to this box legally without overwhelming the size of this box, be it metallic or non-metallic. A couple of things I want you guys to highlight before we go ahead. This is Article 4, 314.16, number of conductors and outlet devices. So it talks a lot about all the calculation, how to size it. But the most important thing in this article that I'm going to highlight is what counts and what not counts. And I believe this is a quick review for you. So let's go directly into this part right here. Box fill calculation. Box fill calculation, my friends, conductor fill. If you read through all the way through B1 through 5, if you guys read through 1 through 5, it tells you the following things that you already probably know from box fill calculation. If a conductor enter the box and pass right through the box, it count as one conductor. Just quick review. Conductor enter the box, pass through the box, it count as one conductor. Conductor enter the box and terminate in the box, sits there, count as one conductor. A device, if I put a receptacle or if I put a switch right into this box, this receptacle or switch count as one device, two volumes based on the conductor landing on this device, right? These are quick review. A device count as two conductors, two volumes, two conductors based on the conductors landing on this device. All equipment grounding conductor count as 1. Wire nuts count as 0. Internal clamps, if you have an internal clamps that you have to tie your cables to, they count as, all of them count as 1, based on the largest one into the box. If you have a box and you have a fan or a light and you have a hickey and a stud, and there's a nice pictures, guys, in your book about hickeys and studs. All hickeys count as 1 in a box and all studs count as another 1. Okay, what did we forget? If a conductor, this is the most common mistake, if a conductor enter the box and loop 12 inches or more, it count as 2. That's the most confusing one. So these are really the most important things in that conductor, each conductor. And we talked about this one, guys. Each conductor into the box count as 1. So I want you to highlight this one if you have not seen these before. So I'm going to go directly into my highlighter and view. Okay, where's my document tools? Tools, annotate. Okay, mark text highlighter. So conductor fill, guys, splice. Highlight the first one. Unbroken shall be counted as once. Each loop or coil count as 2. So this is the most important one. If it pass through, count as 1. If it loops 12 or more, it counts as 2. Clamps, all clamps count as 1. Clamp fill. Support fittings, hickeys, and studs all count as 1, right? Device fill, they count as 2 based on the conductor landing on them. If you read through it, equipment grounded conductor all count as 1. If you have, except if you have a separate, if you have, guys, insulated, isolated grounding conductor, it counts as an extra conductor, which we do sometimes. Any question, guys, about this? Any question? There's some exceptions. So these are really the major things before we go directly to the calculation. This exception they always catch you on. Equipment grounded conductor or conductors or not over 4. If you have not more than 4 conductors, number list smaller than number 14, so number 16 or less, coming from a box that has domed canopy, which is a light, they don't count. You have 5 conductors, number 16 count. 4 conductors, number 16 does not count. So that's only if it's coming from a canopy where it's domed a little bit, so it has enough room. Any question, guys, about this? This is all the rules of the pole box. Any question before we jump in directly into the calculation? Directly to the calculation.
On that support fitting, if you have a stud and a hickey.
A stud is 1 and a hickey is 1.
Okay, so
So they don't both count as one. They count as one each. Good point. Okay, the most common mistake, Phil, is people do, say, suppose I have a box like this, and I'm bringing number 10 conductor and landing it in this box, on a switch. Okay, so the switch now count as two conductors number 10, and the equipment grounding conductor in this area count as what, all of them count as one conductor based on number 10, the largest equipment grounding conductor in the box. Okay, if you have metallic boxes like this, guys, the code give us a table that you can go and find how many conductors you can put on these metallic ones. If you have a plastic ones like these, non-metallic, they have the cubic inches inside them. If you guys read, and I'm sure you've seen it before, if you read the device box that I have in front of me right here, it says 22 cubic. This will take 22 cubic inches right here. And if that doesn't mean anything to you when you wire in the field, guys, a lot of us are not going to sit there and do calculation. So the nice thing is that if you look inside it, it will also tell you 11 number 14. Take this. This is 11, just this device. It takes 11 number 14. So if I'm taking the device, this is a device box. It says 11 number, number 14. 11 number 14. So this is, take this, guys. I have a receptacle. Suppose I'm going to put a receptacle. So here's my receptacle. My receptacle is count as 2. Suppose this receptacle was in the bathroom. So it's a GFCI number 12 conductor. So 2 times, so that's going to be 2 based on number 12. So this is going to be 2 based on number 12, right? Because I'm wiring, here's what I'm doing. I'm taking a GFCI receptacle and wiring it with a 20 amp circuit. 20 amp circuit. Here's what I'm calculating. 1 GFCI receptacle, 20 amp circuit. This will be number 14, number 12. 2 conductors, number 12, right? Okay, so let's see. Receptacle is 2. Conductors. How many conductors when you bring 12 2? 2 conductors. Here's my 2 conductors. Ground. How many grounds do we have? 1 ground. Clamps for this one. There is no clamps inside it, so it counts as big fat 0. So no clamps. Anything else in this box? That box that you're looking at right now. Anything in this else, guys? So if you add them up, you end up with 5 conductors based on number 12. Now, if you look right inside this non-metallic box, and it will tell you guys, if you're using number 12, you can have only 9. 9. So only 9. Take this. So suppose I want to steal power come from here and take another number 12 conductor, another circuit, going somewhere else, right? To feed somewhere else. So here's another 2 conductors. So another 2 conductors that will make this, add 2 more. That will make it 7. And keep looking at that box, exactly the one that I'm looking at right now. It says 9. 9 conductors. We're getting close. That box right here can handle only 9 conductors. We're getting close. 7. Add 1 more number 12. 1 more number 12. And what do? Add 1 more number 12 here. So here's 1 more number 12. So I have 7 plus 2 again. That will give me 9. And you are at max. So here's a box, a device box, 1 GFCI in it, and 3 conductors number 12, and you max the device. Does that make sense, guys? The reason why I said that when I think it's you, Nick, when you were bringing all these conductors to one box, be careful, guys. The rule, a best electrician, if you want to wire things, the best way to do it, especially with these device boxes, is to come in, come out with 1 cable in, 1 cable out. That's the best way to do it with these device boxes. Did you guys hear me? 1 cable in, 1 cable out. 2 cables coming to a device box, like 1 device box. 2 cables per device box. So 3 cables you'll be able to do 3 cables too, but a good design is 2 cables per box. 3 is okay. You start putting 4, start questioning your number of conductors that you can fit in this. A device box. Any question, guys, about this? So we done the calculation for this non-metallic box right on the spot. Any question? So, okay, based on this, my friends, what I'm going to do, this is just a GFCI receptacle circuit. Let's go back into the table that if you're not familiar with, if you have not highlighted it, please do so, because You're not going to hear Chad talking about it again. This is one of the most important tables in box fill calculation that you're going to encounter right in here. The way this table works, if you have, this is the box. If you have a device box, an inch, let's go directly into a device box, 3 by 2 by 3.5. So if you have the deepest device box, 3 by 2 by 3.5, okay, then the volume for this baby is 18, right? And the maximum number of conductors, suppose the maximum number of conductors number 14 is 9, and number 12 is 8. Number 12 is 8. This was slightly different because it's non-metallic. That guy was slightly different because it's non-metallic. Any question, guys, how to size this? So suppose here's that table. This is how we're going to use it, the device boxes. But let me take a quick example right on the spot here. Suppose, guys, you have with the same calculation right in here. Suppose you have a box, and you're going to grab a cable. Here's cable 1, cable 2, cable 3, cable 4, and I have a device, a receptacle here. Okay, I have a receptacle, and I have all these 4 cables coming out of this receptacle. Take this. Each one of these is number 12, 12, 2. Each one of them is 12, 2. Each one of these cables 12, 2. Have I exceeded? And this receptacle, I picked a deeper receptacle right in here. Have I exceeded? So I have one box, this size, 3 by 2 by 3.5 deep box. And I brought 4 cables, 12, 2, a NUM cable. Clamps are with the clamps, with internal clamps. And we're going to see if we can do that one in this box. Cool? Is that okay, guys? 3 cables, like exactly what you're going to lay out. Take this. The first thing you need to do, guys, is the conductors. How many conductors and why? I have 1, 2, 3, 4 cables. 4 cables, number 12. Each cable has 2 conductors, right? Hot and neutral. So 4 by times 2 is what? 8. 8 conductors. Any question about the 8 conductors? Why 8 conductors? These are 14, 2 conductors per cable. 2 times 4 is 8. All right, let's go to the device. Here's my device. How many devices do I have? I have 2 devices based on which number? Based on number 12. So here's the 2. So basically 2 conductors. By the way, you don't have to cache the allowances if all the conductors are the same size. All the conductors are the same size. I don't need to multiply 2 by 2, this by 2.25 because they're all the same size. So here's 8 for the conductors, 2 for the devices. What else? Clamps. Clamps, 1 for the clamps. Am I missing anything? How about ground? All your ground is 1. Am I missing anything? No? Okay, so add them up. 10, 12. 12 conductors. How many conductors can I put number 12 in this box? 8. Oops. Okay, how do you correct this problem? You guys are designers. You're going to be laying out, and remember how Phil, when I told you I want you guys to lube them. That's when you lube them. You start thinking like an electrician. If you're an engineer and just putting a circuit number next to them, how would you decide? How would you know that you just exceeded that deepest box that you can have, the deepest device box that you can? That's the deepest device, metallic. Okay, so how do you mitigate the problem? How do you mitigate the problem? I need to reduce my number 12 by what? 4. I need to get rid of 4 conductors. So here's conductor. This one is get rid of, and I'm going to get rid of this conductor. So if you have a device box, right, by getting rid of these 2 conductors, 2 cables, I cut it by 4. I still meet my number 8. So I'm 8. So take this, that. Then a box like this, the deep box, you cannot bring to it more than 2 cables, number 12, and a device. Can you guys see that? The gravity of it. I know you have done the calculation. I'm not interested in the calculation. I'm interested in the gravity of what you do. That's what you just, I saw this one with Nick and a bunch of you guys bringing all these cables to one device. You're going to be thinking, can I fit this? And we're talking about one device, one metallic device. And have one metallic one metallic device, similar to this, Deber. One metallic device like this. So no more than 2 conductors with the clamps and inside clamps. Any question, guys? Any question about the gravity of using it? Okay, let's use another example. If you guys don't mind, take a snapshot on that one. Yes, sir.
If you have this kind of situation, how do you manage?
Here's how I would solve it if I was in the field. If you guys are, if you're wiring with number 12, if you're wiring number 12 in the field, number 12, always come with cable in, cable out. You almost always guarantee to into one box. If you have 2 boxes, multiply this by 2. If you have 3 boxes, multiply by 3. Ganged, right? So if you have 3 boxes and you're wiring with 3 ganged boxes and you're wiring with number 12, 2, multiply this by 3, that will give you 3 cables. You can, 2 times 6 cables I can bring to that 3 gang box. So no more than 2, number 12 in one box. That's rule of thumb. If you're wiring with number 14, 3, no more than 3, and you're almost always guaranteed you don't have to mess with this. No, how would you solve the problem if you're in the field? If you have this, how would you solve this problem? Well, you have to, the best way to do it is rewire, because you can't get deeper. You can rewire, take these 2 cables and rewire them somewhere else. You have to look at, how you bring it 1, 2, daisy chain them, take them from a different location. Instead of taking that cable from this box, maybe I can tap into it from the other box. It's just bad design. Deber box, you can change this one into a Deber box with a mud ring, but that's a whole different solution. So rewire, the best way to do it is rewire these 2 cables, take them from a different box. Any questions about this? Let's take one more example. I have a conductor and I need a device. This time, let's use. Okay, here we go. That one. Let's use the same calculation that I did, except I'm going to have, guys, number. I'm having number 9, and here's what I do. I have a 3-way switch, right? A 3-way switch device here, switch, and into the switch, I have coming out of the switch, since it's 3-way switch, I have 14-3, and I have 12-2, and I have another 12-2, and another 14-3. Is this box overloaded? And my box, we're looking at that deep box, same box, deep box. Is this box overloaded with conductors? Right here. So number of conductors. How many conductors do I have? 3, 3, 6, 2, and 2, 4, 10. 10 conductors, right? Number 2, devices. How many devices do I have? 1 device, 2 conductors, ground. How many grounds do I have? All of them count as 1. Clamps internal. Clamps. How many? I have 1. So you end up with what? 14. 14 conductors, number 12. Have I exceeded the maximum depth of a box that I can do? Yes, and they're number 14 with a switch. Typically, we wire with a switch number 14. Right? Okay, how many conductors am I over? 5 conductors to mitigate the problem. How do you solve the problem? I'm over with 5 conductors. I need to get rid of basically 14-3. So if this is a four-way switch, so you need to get rid of 2 and 2. Did I say 14? This should be number 14, not 12. Sorry. All of them I need them to be number 14. This is 14, and this is 14. 14, 2, 14. All of them are 14. So how do you solve this problem? You will need to get rid of almost 5 conductors to make the system work, right? 5 conductors to make the system work. 5 conductors. So the best So you might have to get rid of this, reroute these two cables, reroute these two cables, reroute these two cables. Any question, guys? Any question about that? Or you can get an external clamps and get rid of the clamps. If I need a three-way switch, no problem. I can do this one and put an external clamps, then I can get rid of the clamp, one for the clamps. You can't get rid of the device. The device is there. Any question about the gravity of what we're doing here? Of sizing conductors? If that box, 11, 14, how many do you have? 14. If I have a plastic box like this, that's okay. D box, this can get number 14, 11. Oh, this one actually, no. 11 conductor number 14, no. Still exceed that one. Takes 11 on that one. Any question, guys, about the boxes? Box fill calculation? Okay, so everybody knows how to use that one. That cable, obviously, if you have number 14, all of them. This cable becomes very handy, Chris, if all the conductors are the same size. Very handy. You have your round octagonal boxes right in here, and you have your square boxes that you can use for commercial industrial. So these are the most important boxes, the ones at the top and a couple of others way at the bottom. But 99% of the time, you're going to be right in this area. Oops. Whoa. Not where it's at. That was a big move, huh? Okay. All right. Divide boxes. Okay. Any question, guys, about this table? So if all your conductors, if the box has conductors of the same size, you're going to use this table. Now, if your conductors are different sizes, if the conductors enter the box are different sizes, then you need to cache the allowances for these conductors. I call it cache allowances. So take this. Here's my receptacle here, my device. I have conductor number 12, 2, and for whatever reason, I'm also coming here with 14.2, with 14.2, and I have a device. This is my device. 14.2 and 14.2 and 12.2. If the conductors are different, then you have to do the cubic inch calculation. The cubic. Let's do it. Let's do it for the same conductor. I like this box. Here's a box. Here's a device. Now I no longer can use the number of conductors, guys, that's coming based on which size. How many conductors, which size? You have no idea because they're different sizes. Okay, so let's apply the same rule. Suppose let's start with a conductor. In this case, we start with number 12. How many conductors number 12, guys, do we have? 42, right? So I have 2 times, what's the allowance for number 12 right here? The allowance for number 12 is 2.25. 2.25. Okay, now we go to the conductors number 14. What's the allowance for 2 conductors? I have 2 conductors. What's the allowance for number 14? The allowance for number 14, Chad, is 2. Okay, now let's go device. Suppose my device was a receptacle. The receptacle I'm landing. Okay, we need to decide here. Let's land the device number 12 on the device. So the device will take 2, multiply it by 2.25. Okay, do we have a ground? Yes, ground. That will take 1 based on the fattest, fluffiest conductor in the system, 2.25. Do I have a clamps? They're supposed to have a clamps, internal clamps. So clamps, and this also 1 times the largest, fattest conductor. Okay, here's what we have inside this device. I need somebody to do the math for me. Here's a device. Just like you guys were laying out your receptacles, you brought a 14.2 cable, an AM cable, as well as 12.2 internal clamps to a box like this, deeper than that, a box like this.
is the strap on is the 14 on the device or 12 on the device?
The 12.
12.
I landed the 12 on the device. Okay? Anybody can give me the math? The total? What's the total? How much?
17.5.
17.5 cubic inches. Perfect. 17.5 cubic inches. Can you see what that conductor can carry as a cubic inches? I mean, what box can carry? 18. Is this box crowded? Absolutely. How much?
97%.
97%. From 18. No, 18. I have 17.5. No, it's not. I can put 18 cubic inches. I have 17.5. Is that okay? That's okay. It's not crowded. It's okay. Can you guys see these two numbers? I was looking at. Look at these two numbers. You want the 17.5 cubic inches, if we did the math right, to be 18 or less. Are we okay with this installation? Yes. Add one more cable, and what do? You screw up the whole system. Any question, guys, about how to do the calculation of the conductors are the different sizes? The same thing if you have a non-metallic. If you have non-metallic there, you have the cubic inches right inside them. And the conductors are different sizes. If the conductors are different sizes, then you have to use a cubic inch. If the conductors all the same size with device and clamps, it's so easy, guys, to use the cable directly under that particular number of conductors. Any question? Any question about that? Okay, let's do something more industrial. And I want to go to a square box as a J box. I'm using a square box as a J box. This comes handy, guys. And let's use one square box, not over wide square box. This is commonly used square box. This one, and I'm using it as follows. Right? I'm going to use this square box. I'm using EMT, and take this. Here's my box. Here's my EMT conduit 1, EMT conduit 2, EMT conduit 3, EMT conduit 4, right? This is my box. 1, 2, 3 conduits coming out of it, typical. And out of each conduit, guys, I'm going to bring conductors. Let's bring a hot, two conductors from this, no devices, nothing. 3, 3, 3, and 3. So, okay, so I'm bringing three conductor multi-wire branch circuit. I'm bringing a multi-wire branch circuit. 3 conductors. Now going from, so let me just show you if I am to design this system. So suppose I'm coming like here. Here's my 20 amp. See how this typically will be a 20 amp circuit. And you're bringing your hot and your neutral to this device. And let's add the third one and your other hot to the same device. This is 3-phase. And you need one more conductor here. Where am I? Okay. And 1, 1, 1. So I have 4 number 12. I have 4 number 12 in each one of them. Okay? I have 4 number 12 conductors coming to this box. Why would you do something like this? Why would you do something like this, guys? A four conductor means a 3-phase circuit. Phase A, phase B, phase C, and a neutral. And I didn't show the neutral here. Let me show the neutral. Here's my neutral coming in. Neutral. Here's what I'm bringing. I'm bringing a 3-phase circuit into a J box, commercial. And in this J box, I'm splitting to go feed more lights and or more receptacles. This could be a lighting circuit or receptacle circuit. 277 light, 120 receptacles or 120 lights, or 277 lights only, right? Typical. And I'm using this box, typical box, 4x2 1/8 square box, as a box right here, and I'm using EMT conduits. So kiss the clamps goodbye, no clamps, because we're coming through a conduit, right? there is a lock nuts and the connectors. So no clamps, no devices, because we're not devicing in this box. All what we're doing is just a J box. We're using it as a J box. Okay, let's see if we exceeded the limit for that baby or not. All right, so let's start with conductors. All the conductors are number 12. All the conductors, by the way, are number 12, typical. So if all my conductors are number 12, conductors, how many conductors do I have coming into this box? 4 times 4, 16 conductors. Do you guys have any issue with that? 16 coming, and they will be spliced. I have 16 conductors, typical. How about ground? The EMT is the ground. You don't have a ground. EMT is your ground. What else do we have? Do we have any devices? Do we have any devices? We're not putting any devices in it. So 16 number 12 conductors. Is this okay? Is there anything else in this box? No clamps, no hickes, no studs, no devices, other than 16 conductors, number 12, and the equipment grounding conductor count as the EMT. We're using an EMT as an equipment grounding conductor. Number 16. Is this box okay for number 16? Where are we here? No, here we go. We are going to this box. This box, number 12. Can I do that? No, on this box. Okay, so what's the solution? The question is, okay, I can't do it. What's the solution? How about if we go to a wider box? Let's go to a wider box. Can I use this wider box here? Right here. Can I use this wider box? So I went to a wider and deep box. Can I do that? 18. So in a case like this, what do you need to do? You need to go a deeper box. So if you're wiring with this system, and this is, guys, as deep as you can get, as good as, I think, as good as you can get, you're carrying 3-phase circuits and moving them all over. And splicing them here to do whatever you need to do. In a case like this, it might be a good idea. It might be a good idea to move with a wider square box. Any question about that? Does that make sense? Any question? So that's basically what I wanted to mention, guys, about the pull box calculation. Take it from a point of view of an installation and design. So as you move through conduit, here's my advice for you, Ashley. As you move through commercial industrial, always use deeper boxes in the J boxes. Always use a deeper box. The deeper the better, because you're pulling your conduit. It allows you 3/4 inch conduit, allows you to pull a whole lot of conductors and move anywhere you want, so if you have a deeper box. Now, I'm sure Zach is saying, Chad, well, that's a lot of conductors splicing 16 out of them. Some of them might go through. Oh, yeah. But if you account for the worst scenario, that's a worst scenario. 16 conductors standing looking at you out of a J box. You know, they need to be spliced, going everywhere. So, and this could be probably receptacle, most likely, or lighting. Any questions about this? Now, if I install the number 14, God forbid, for this commercial system, the only difference, guys, you do is, instead of now going directly to the table, if you install number 14, you're going to use the cubic inch right in here. So you're going to start using the cubic inch 42 or the cubic inch 30.3. And again, we're using it strictly as a J box and covering it. Any question? Any question, guys, about these two tables? So if you are running a system like this, go for get a wider box, deeper, bring your conduits that allow you the worst scenario. I know some of you, unless you guys are project manager, foreman, well, if you can become a foreman, as an engineer, this is called material. As a designer, you don't go deeper into that. As a designer, when you go to shed coolers and they don't go inside the boxes for the electrician, that's going to be your work. But if you're working for an electrical contractor, you could be part of your job is to size these boxes, especially as we move towards Revit and trying to integrate all these systems together. That becomes very handy. Any question, guys? Any question? So these are the most important tables here. And if you don't know how to use them, please get used to these tables. If you have not highlighted this second table, please do so. This has come very handy. This has come very handy. And I want to bring to your attention, Chris, look where this table ends. Can you guys see where this table ends? It ends at number 6. What happens if you bring number 4 to a box? What happens if you guys bring number 4 to a box? Whole box. That's why it stops at 6. If you read through the chapter, guys, it also tells you if the devices, they want to make sure, even with all this calculation, you have ample amount of time, of room in your boxes if you have a bigger boxes installing it. But that relates to the installation, not to you. Okay. I'm going to take one more example, guys. I'm going to give you 5 minutes break and take an example, and then we'll close this chapter. Any question about these? Everybody knows where the tables are, what counts and what not counts. We reviewed them, right? So let's take one more example to a box after we take a quick break here. I have a 5-gang box. 5-gang box, 3 switches and a receptacle. Granted that we can find the cover for this one. 5-gang box, 3 switches and a receptacle. The switch, all the switches are wired with 14, number 14, and the receptacle has a circuit coming to a 12-2. And I have three three-way switches, each one of them coming 14-3 to each one of them. And I have a single way switch. I have 42 taking the power out to go to a light, right? So we're bringing a lighting circuit here, and we're feeding 1, 2, 3, 4 lights, turning on and off. 2 lights from a 3-way switch, and 2 lights from a single-way switch. And to make things more interesting, I added a receptacle in the same alignment. You guys know that you can take the cover out of these and gang these boxes. The boxes that I'm using, that box is actually the deeper box. I'm using 3 by 2 by 3.5 deep box. The question is, would that box be good enough for this arrangement? So, any question out? These blue things are the clamps. My clamps are external clamps. I have an external clamps, and I'm using raw mix and NAMP cable. Raw mix and NAMP cable. Okay, shall we do the calculation for that one quick? All right, so let's start with the conductors. I always start with conductors. Conductors, guys, calculation, there's 2 calculations. There's number 14, and there's number 12. For number 14, you guys agree with me? How many conductors number 14 do I have? 3, 3, 6, plus 4, 10, plus 2, 12, right? Everybody agrees I have 12 conductors number 14. I have 14, 3, 2, 14, 3, that will give me 6, and 3, 14, 2, that will give me another 6. 6 plus 6, 12 conductors. Am I right? So I have 12 conductors. 12 conductors. The allowance for number 14, as we all know, is 2.0, right? So 12 times 2.0. Why 2.0? Because, right? Did we do it right?
I'm counting 7 14, right?
This is 12 2.
Yep. Yeah.
So I have 3 plus 3, 6, plus 4 here, 10 plus 2, 12. Just conductors, no equivalent conductor.
Okay.
Well, I'm not counting yet. I like to separate them, guys.
Oh, I see.
I just put in conductors only now. Okay, number 12. Do you guys agree with me? Number 12 is only 2 conductors. 2 conductors. What's the multiplier? 2.25. Okay, straightforward. So this is for conductors. Let's go all the way down for grounding. I call it equipment grounding conductor. Equipment grounding conductor. It's always 1, and it's always based on the fattest, fluffiest 2.25, number 12. So you base it, it's only one based on the largest conductor into the box, right? What else? Clamps. Do I have clamps? 0 for the clamps. I'm just going to write them here so I know. Clamps 0 times 2.25. Why? External. We have an external clamps. So I have 0 times 2.25. What else do I have? Equivalent ground conductor, external clamps. I have devices. Devices. Let's count the devices. I have 2 types of devices though. I call them devices, and I'm going to say number 14, based on number 14. Devices based on number 14 here, guys. How many devices based on number 14 do I have? I have 1, 2, 3, 4. 3 three-way switches and 2 single-way switch. So 4 devices based on number 14. So I have 4 times 2 because 2 allowances for every device. And number 14 is always 2.0. So 2.0. This is an O, Chad. 2.0. Any question, guys, about that? 2.0. Any question why we had 4? Because we have 4 devices, right? 1, 2, 3, 4. Why do we have 2? Because every device have 2 allowances. And why do we have another 2? Because the allowance is based on the conductor landing on that particular device, which is number 12. I'm telling you, all these are number 12, right? You can see how it's landing on number 12. Any question about devices based on number 14? Let's go again, devices. Devices based on number 12 this time. Based on number 12. Devices based on number 12. How many devices do I have based on number 12? I have 1 device, right? And based on number 12, it's 2 allowances, and number 12 is 2.25. Any question, guys, about that, right? 1 device, I have a receptacle based on number 2 allowances for that device, and that allowance is based on number 12. Any question, guys?
Yeah. I don't know how you got 12 or 14.
The 12?
Yeah.
Okay, let's count. Here's a 3 here, and another 3, 2 3s here.
Okay.
So 3 and 3 here, 6 plus 2, 8 plus 2, 10, right? Plus 2, 12. These are 14-2 cables, hot neutral. Did we forget anything, Chris? Okay. Any questions about that one? So did we account for everything else? Do we have hickeys? No. Do we have studs? No. Do we have a domed canopy? No. Do I have conductor passing through? No. I don't have any of these. So I need somebody, 2 people, to give me the total. All of them together. All together, yeah. Chris, what did you calculate? You came up with?
51.25.
How much?
51.25.
51.25 cubic inches. Anybody came up with something different? Phil? 41. What did we do? Did you count? This is 0. Don't forget that this is 0. I need another gentleman or lady to substantiate, guys, the calculation. Yes? 51.25. Okay. Phil? Okay, so that's 51.25. That's how much volume I need for all these babies put together. That's volume needed. So I have volume. The volume needed is this amount of volume I need based on the design. Any question, guys? Let's go see if the box has the same volume yet. So for the box, I want to do the box right here, guys. I have how many of them? I have 1, 2, 3, 4, 5. 5 gang box. I'm going to do it differently, in a different slide. Okay, let me know when I can move to the next slide. So what I'm going to take, I'm going to take the volume for each one of these, multiply by 5 behind, because I ganged them 5 of them. So I have 3 by 2 by 3.5, 3 by 2 by 3.5. Their volume is 18. If you multiply this by 5, 50, 90, 18 times 5,
Well, that box,
90. That's what I thought. 90.
what box size?
The 3 by 2 by 3.5. I'm using a Deeper box. Okay. Okay. It's any question, guys, about how did the calculation? Straightforward. Always, it's a very good idea to have your clamps outside, guys, because putting a clamps inside is not a good idea unless you have, especially with these. You can see that the clamps come right outside. So when I gang them, I can put my clamps outside, no problem. Okay, we ganged them out, 6 of them, 5 of them. Cool. So this is the volume that I need. Can I jump into? Are you guys all done? Anybody need more time? Okay. So 3 by 2 by 3.5. Let's start with my box. My box is 3 by 2 by 3.5 inch box, device box. If you guys take this box, it's an 18 cubic inch from table. As we all know, this is coming from table 314.16a. Table 314.16 and 8. 314.16a. Okay, so that's for one of them. I want to remind you, gentlemen and lady, that we have 5 of these. We're ganging 5. Multiply this by 18. That will get you a 90 cubic inch. This is the box. This is the box volume. Well, the box is the ganged box is volume. The ganged box is volume. Come on, Chad, there we go. Ganged boxes volume. This is my ganged, it is still ganged, right? Ganged boxes volume, 90. Right? Are we okay with this? What do we need? What did we need? We needed to occupy only 51.25, and we're only occupying 90 is as much as I can do. Great. We're cool. Now let me ask you guys. Can you gang a shallower box? Since we know that, which box would be a good choice for this one? Let's go for instead of doing the 18. Remember what I need. I need 52, right? So if you take the 52, I mean 51.25, 51.25. Come on, calculator. Now to decide it to 5. 51.25, right? Divide this, my friends, by 5 of them. So you're looking at, go look at a device that can give me 10.25 or larger. A device box. 10.2 or larger, 10.25. I can't use 3 by 2 by 2. I bet you if I use the 3 by 2 by 2 and a quarter, I'll get there. 3 by 2 by 2 and a quarter. Okay, so 2 things here I want to do. Number 1, my box is cool. Number 2, find. So here we are okay, Chad. We're okay with this box. Now, step number 1, 2, the thing that I want you guys to do, number 2 here, find more suitable. It's better. Suitable box. Find a more suitable box for this installation based on what you're doing. Here's what I would do. More suitable box. I take the 51.25. Since I'm ganging 5, I have no chance except divide this by 5. That will give me 10.25, right? 10.25. That'll give me 10.25. Did they get that right? 10.25. Find more suitable box that you can gain. Okay? And if you take this one to table 310.16a, device, remember we're looking at devices. So if you look at under devices, my friend, you can get 3 by 2 by 2 and a quarter. I can have 3 by 2 by 2 and a quarter is my more appropriate device. Right? Can you guys see that? Everybody can see that? The more appropriate device would be 3 by 2 by 2 and a quarter. For this type of installation. Now the worst thing is you're going to be carrying 2 sets of devices. If you're doing boxes like this, use a deep box and move on. Or if you, I mean, a box like 2 and a quarter is not a bad box to start with too. Any questions about this? So find a more suitable box. That's how we find it. Divided by 5. Now again, now remember, I want to remind you guys, we're ganging 5 of these babies. Ganging 5 of these babies. Putting them all in one gang box. Right? 5 of these. Any question, guys? All right, now suppose that we're still using the box before. We need to know how many extra conductors we can add to use it as a J box. I single-handedly decided to start throwing conductors and so forth. I want to see how many conductors can I splice right into that baby. Splice, just use as a J box. Okay? We're gonna do it based on the deep box. Yep, based on the deep box. Any question, guys, about step number 2? Step number 1, I'm asking you, is this box okay? Yep, it's okay, Chad. Step number 2, okay. We found it's huge compared to what we need. Can you find more suitable, more appropriate box? Yep, Chad. Here's how we find it. Take that volume divided by 5, get you 10.25. That will get you a device of 3 by 2 by 2 and a quarter. Okay? Now, the third thing I want to find from the same example, guys. The third thing, we're going to go back to my original box, which was 3 by, what was the box again? The original one, 3 by 2 by 3.5. Back to my original design, 5 box design. 5 of these. 5 of these get together, which is right in here. 1, 2, 3, 4, 5. And I remember we brought one here, and one out, right? Okay, so that's the original design. Now suppose I used it. I want to ask you, gentlemen and lady, how many conductors, number, we're using 12, let's use, you can't ask, if I ask you how many conductors number 12 and 14 you can bring to a box, you're going to tell me, Chad, we're going to be using, this is 2, you have to give me one more value, because 2 unknowns in one equation. You can't solve 2 unknowns in one equation. So I can only ask you how many number 14 at a time you can bring, or number 12, but not 14 and 12 at the same time. So suppose I want to bring number 14, guys. 14, number 14 conductors. So I want to ask you, the question is, how many number 14 can be brought to this box? How many number 14 can I bring to this box? How many number 14 can I bring to this box, right? You guys have done a few questions like this. How many extra number 14 can I bring to this box? Later on, I'm going to ask you how many cable you can bring to this box, because we're not using conduit, we're using cables. Okay. So the rule, guys, is here's the steps that we use is available. Okay, or boxes volume. Boxes volume, and you guys agree with me, it was 90 cubic inch, right? The boxes volume was 90 cubic inch, right? Remember, the original box volume, cubic inch. All right. Occupied, occupied, I know how to spell that. Occupied volume. The volume that has been already used by the devices and the switches. What was it? 51.25 cubic inches. Right? That's just listing what we have done. Now, the last box that you need here is available volume. The available volume, as you guys can see, it's subtracting these two from each other. Subtract. What's that, Chris? The difference between them? 38.75 cubic inch. This is how much volume I'm allowed to fill. Right? Piece of cake, just the difference between them. Okay, so that's step number one. Find how many volumes, the volume that you're supposed to you can fill. So step number one. Step number one, find the volume that you can fill, right? That's a piece of cake. Get the occupied, subtract them from the volume of all the boxes. You get 38.75. Okay. The last thing, step two, my friends. I'm going to put it right here. Step two is number 14. How many number 14? Piece of cake, you take the 38.75, divide this by, what's the allowance for number 14? 2. And remember, they're not passing through. They're coming to sit there to be terminated. Either spliced and pushed in or land on another three-way switch. Then I'm going to change these into a three-way switch, or just a neutral. Remember that neutral that have to be pulled with the equipment, right? Okay, so divide this by 2. Why 2? Why do we divide it by 2? Because 2 is the allowance for number 14. What's the answer? 19.375. I don't know, guys, about you, but 19.75 is not a conductor that I can carry. So that will be 19 conductors. 19 conductors. 19 conductors, right? 19 conductors. Now I can't put devices here because you have to add another volume for the device to be mounted. 19 conductors. Now my question would be, guys, for you, how many cables are these 19 conductors? How many cables? You're going to tell me, Chad, do you want to use 14.2 or 14.3? Let's say 14.2. How many cables of 14.2 I can put? You take the 19 divided by 2 will give you what? 8. So 8 cables, 14.2. How about 14.3? Take the 19 divided by 3, right? That will get you 6, right? 6 conductors. So just to give you an idea, guys, I'm going to use, you can use as many examples as you want, but here's what you can add. So I'm going to add, in a case like this, I can add up to 6 times 3, 18, right? 18. I can add 6 conductors of 14.3. I can add 6 conductors of 14.3, right? 6 times 3 is 18. I can't fill more than 19. I'm good. I can add 6 more conductors. 6 more cables. 14.3. 6 more cables. 14.3 to the arrangement. Does that make sense, guys? 6 of them. Why this is important? Take this. Remember these was S3 here and S3 here and S and S. Suppose I want to change these one to S3. I need more conductors, right? Now with the neutral. Remember, there's a neutral. To make the system work, I need a neutral coming. Here's another conductor. So suppose I want to make this one right now. I want to make this one 3 and this 3. What would that add to my original design? It's going to add 2 more conductors. going to add 2 more conductors. So, but I have 19 conductors to go. Suppose I want to steal a circuit from here, like I said, from here and go up and feed something else. So that will give you an idea how many cables you can bring to this arrangement. Any question, guys? Any question? See how nice about having a deeper box where you can have the luxury of stealing power, go from point A to point B? Any question? So I hope, guys, I know this is not the first time you've seen it, the box fill calculation. You spent some good time, right, Chris, on it? So this is a fresh refreshment. As we go, guys, through the year, when I start throwing, tell my friend, when we wire with conduits in the ceiling, I'm going to ask you, when you design your system, I said, with that box, what box do you need for this? As an estimator. You're the estimator. You're going to be picking these boxes for estimation, guys. When you do your takeoff, you're going to be picking a box for takeoff. And the boxes are going to be a lot of options. Which one would you use? Most of the time, move around with, especially commercial industry, with deeper box, you're good to go. Any question, guys? Any question, my friends? When you guys doing the full, everybody had the chance to look inside these and find? Did you guys all? Do I need to pass these? Everybody has a chance to look inside them and see the number of conductors and the cubic inches for these non-metallic. And of course, the hardware, these device boxes and square boxes. There's tons of combination for them. I want to remind you the tables, guys, are for metallic boxes. Non-metallic boxes are stamped inside them with at least the cubic inches. So if I want to find how many cubic inches for this baby, I don't go to the table. I'm going to go look inside it, and this device box, deep device box, it will tell me 20 cubic inches. 20 cubic inches. Any question, guys, about box fill calculation? So as you start laying out your when you guys lay out the wiring, keep in mind, as I said, if it's a good design, always to, especially residential guys, come in with a cable, out with another cable, maybe a third cable, especially if it's not number 12. But that's the best design, is in cable, out cable with these residential ones. Then you don't have to go. Otherwise, you have to do a deeper box. For number 14, guys, 3 cables coming to the same box, not a bad idea. You go higher than that, it becomes, you have to have a deeper box. Any question? Not to mention this will be my receptacle continues to sit right here. Now, some of you would say, why would I put a receptacle right at the top? For whatever reason you want. You know, suppose that one right in the countertop, and you want to put a receptacle right there to be part of your countertop, GFCI receptacle. Any question, my friends? If you guys don't have any question, I'm going to switch track and go over a few code requirements for review of code requirements with emphasis on I guess we continue doing emphasis on the box fill calculation. But that's all what I need to cover in terms of box fill calculation. So we know how to use the tables, everybody, guys, and you know how to use them. If all the conductors, if everything in the box is the same conductor, don't you ever do this calculation. It will be wasting your time. Go directly to the tables. If all the conductors in that box are the same size, for example, a good example would be a J box in an industrial, guys. Square box in an industrial, everything we pull is 12. Lighting and receptacles most of the time, they're number 12, so it would be wasting your time to do the calculation this way. Now, deeper boxes or wider boxes, guys, required for certain application. For example, if you go to range box, you need a wider box. So if your device is larger than number 2 inches, then you have to end up with a two volumes for it. If you read through the code, it tells you if it's larger than 2 inch your device, then you have to go double the allowances. So you start giving 4 allowances for the device instead of 2 allowances. And that will put you guys in a bigger box, like range boxes, as well as dryer boxes. These are big devices that you can get. When we say what I'm showing right now here, guys, is the typical receptacles and switches, 2 inches or less. You get a bigger device, you have to have a bigger box. So that's all what I want to do in terms of box fill, guys. Let's go. I'm going to switch track and go directly into chapter 9. And it's all related, guys. We're still in the code. Chris, I was doing prep for one of my apprenticeship classes, and it talks about how to prep an apprentice to be a supervisor. Apprentice will turn into a supervisor when you get your journal license, because now you can supervise 2 people. Before that, you're a grunt. You can't supervise anybody, electrically speaking. Okay, so in the analysis, it says something that I knew for a fact is people return, on average, people return 25% of what they're told. So you guys have just returned 25%. If you haven't known it before, and this is when you went with Gary and all this stuff, if you retain 25%, and now I went over and you retain 24%, 25%, hopefully over time it accumulates. So what I'm saying, the reason I'm saying this one is if what I'm going to be going right now over, we covered it, and we're going to keep hitting it over and over. The theme of this quarter is residential. So 25, if you keep adding 25, hopefully we'll add up to 100 at one time. Okay? All right. I have lighting branch circuits for master bedroom. I want you guys to tell me the requirement for the code for master bedroom. Number 1, do I need an arc full circuit interrupter? Yes, an arc full circuit interrupter. Number 2, do I need a GFCI receptacles in the bedroom? No. Number 3, do I need a light in the bedroom? Yes. Do I need a switched light? Yes. Can the light be switched receptacles? Yes. So that's basically what we're going to be doing. And then the code requirement is 1 light. Receptacles. What are the rules for a bedroom receptacle layout? 6 by 12, right? 6 from every opening, 12 in between. Every 2 feet or more, you need a receptacle. That's it. Any other rules for laying out receptacles? So that's basically what this chapter is, taking that bedroom, guys, and analyzing it based on the code, arc full circuit interrupters, wiring diagrams, layout. Now you might agree, you might disagree with the way they do it. There's a few things they add the load on the circuits. I haven't been too keen on adding loads on residential circuits, just because residential circuits are not a big of a deal. As we go commercial, guys, when you have receptacle, I'm going to be asking you, what's the load for the receptacle? If you don't know what the load for receptacle, it's going to be by code 180 volt amp, unless you know otherwise. So we'll do a load calculation. Box sizing, we just talked about box sizing, as you guys can see. We just went through the box size based upon the number of conductors entering the box and so forth. Number of luminaires and outlets, including the circuits. We said we put no more than 10 receptacles or lights in one circuit, residential, based on non-continuous loads. Okay, here's what I want you guys to give me your full undivided attention. Look at the way they lay out the circuit. Here's my question for you. Question number 1. They have a fan, right fan in the middle here, right? So I have a fan, and let's look how they did it. Where's the home run? I have one home run, A19, coming to a receptacle outside. You can agree with bringing the home run to receptacle outside or not. Is the receptacle outside have to be GFCI, weatherproof, right? Tamper-proof, weatherproof, GFCI, in-use cover. That's a receptacle outdoor. Coming in, I have, because this is exactly like our apartment. There's a light. If you exit, this is an exit, you need a light so you can see as you exit the house. So they have a light. So what they did, guys, if you look at this circuit, they brought a circuit over here. Nick, what do you think? They have two conductors here, a hot and a neutral, and then they have three conductors and two conductors here. So they brought the circuit to this light, came down with a switched hot, and back with a switched hot, right? Why do you have, here's my question, why do we have three conductors here? We need a neutral to go to the switch, right? We need a hot so we can switch it. And what do you think the third one is doing? Taking the switched hot back to the light. Same thing here. Why do you think we have two? Because the hot is already in the switches, right there in the box. I steal the hot, tie it to one end of the switch, and turn the other closet light. Do I have to have a closet light? No, I don't have to have a closet light. Is that a good idea? Yes. We talked about the closet light rules. Everybody knows that 12 inches versus 6 inches. Basically, everything is 6 inches except surface mounted incandescent and LED are 12 inches. Clearances from the storage area. Okay, so we know these guys. Come over here. Then we came from here. Why do you think we have the conductors here? Three conductors. I need to energize this. Here's a hot neutral, right? So I have a hot neutral in every one of these bedrooms. What do you think the third one? Switched hot. They decided to use a switched hot receptacle. Do you have to do that? No. If you decided to do a three-way switch, a switch receptacle, then you have to carry a switched hot. Every receptacle need a hot and neutral, two conductors. If you decided single-handed switch half of it, you need to add a third conductor. Okay, so we brought the hot and neutral right here. So Chris, my friend, what do you think we have a three here? One for the fan, one for the light, and one for this neutral. Because you can have two hots without neutral reference. Good luck. Okay, now why do you think we have these here? And what are they doing here? They're three-way switch. They want to switch the receptacles, believe it or not, the receptacles from three-way. So they have three-way switch. When you have a three-way switch, you need two from the get-go travelers. Okay, so I have my two. I need my neutral here, and I need a switch. We're switching the receptacle, so we're going from here. We're going back from here, and we're bringing my switch receptacle back to all these switches. So these three are two travelers, one neutral, and one switched conductor that's going and switching all these receptacles. Any question, guys, about the way they lay out the design here? So since we were talking about boxes, there you go. Take this box, guys, and analyze it. I have a single gang box. My single gang box have one device right in it. A device. I have two cables, right? And this cable is 14.2, and this cable is 14.3, and this cable is 14. So I have 14.3. I have two cables 14.3, and now most likely the shallowest device conductor will get you a two cable, guys. Analyze this box. Take this, just to give you an idea. Here's a three gang box, 1, 2, 3, and I have 1, 2, and three cables. I have 1, 2. I have here 14.3, and here 14.4, and down in here I came into the box with 14.2. Is that okay for the shallowest box? If you do the math, do you guys see now why we're doing box fill calculation? Because that's where the box, that three gang box that you put right here. Any question, guys? Any question? Any question about this circuit? GFCI and outside AFCI for the whole circuit. So that's basically your circuit. Is this the distances? I want to remind you guys the distance, just a quick reminder that the distance from, suppose that these are movable ones. If this is fixed from here to here, the distance from here to here cannot be more than 6 feet, right? And then right in between these two, 12 feet. This is the 6 by 12 rule. 6 by 12 rule. And then you continue around, and from right in here all the way to the end cannot be more than 6 feet. This wall here, if it's more than 2 feet, you need a receptacle, or the distance between each side of the wall cannot be more than 6 feet. From the receptacle to every opening that goes all the way down to the floor. Any question, guys, about the rule? When you graduate from here, hopefully you have all these rules up and running. Split wired receptacle, talked about, luminaire, ceiling, telephone. Okay, here's how they wire it with the three-way switches. Okay, if you have a glass panels, like here, guys, back down here, right here. If this is a fixed, this right here is, if it's a fixed glass panel here, then you count it as a wall. Fixed. Portable? No. Fixed? Yes. Movable? No, not portable. Movable? No. Fixed? Yes. So you start your counting. See how I put my 6 right from the edge of that glass. If you can't put it in the glass, I think, Chris, you asked me that one. What if the whole wall is a glass? What am I going to do? You're going to put them within 18 inches off the floor, in the floor, within 18 inches of the wall. Okay, not considered wall spaces. If it's lighting, yeah, space allowances. Selection of boxes, we just talked about, guys. Boxes, finish selecting boxes. Fans, a few things about the fans. I don't know how many of you guys, do you do that, Chris? In the winter, you're supposed to put your fan to push the air down because hot air goes up, right? This is not code. In the winter, it's supposed.
The opposite on their level.
Are they?
Yeah.
Well, supposed to push the air down, and in the summer, supposed to push the air up, suck the air up. So when they're trying, I think in the winter here, if it's going, depending on with the fan, if it's going this way, I think it's pushing the air, grabbing the air and pushing it down. If it's going in the summer, I think if it's going that way, it's pulling the air up. Anybody change their fan based on the winter? And if you go guys right to the fan, you can switch it. It changes the rotation. So a few things about the fan, no code, common sense. Winter, push the air down because it's hot. Hot air goes up. In the summer, you're gonna pull it up because it's too hot. The most important things, guys, when it comes to fans, do you guys remember the rules of the fan? Fan boxes have to be listed. So this box has to be listed as a fan box. Fan box. This has to be listed as fan box. If it's listed as a fan box, it can handle up to 35 pounds. Higher than 35 pounds, you have to label it. Okay, so if this is more than 35 pounds, I'm going to go label this one with 45 pounds. All what you have to do, it has to be listed for a fan and stamped with the weight on it. If it's larger than 70 pounds, what do you need to do? Call your structural engineer. You can't support it directly from the box. You have to somehow find a way of supporting it independently of the box. And we talked about the big A fans, so that's a good example of that one. Up to 35, no problem, as long as it says fan box. Higher than that one, fan box, but stamp it with the weight. Up to 70, okay. After 70, call your structural engineer. Okay, what they do is with these vans, guys, they're universal vans. They'll reduce the voltage in them, or reduce the speed for the most part. So if you ever have a fan control, speed fan control on that baby, this is really straightforward. Here's your box. You brought Can you guys see how you brought your hot, you pigtailed your hot to both switches, and you went the switched hot, the switched leg all the way to the light? If you have a fan control, a speed control on the fan, what they recommend you guys to do is also they have a speed control on this one too. The recommendation, guys, by manufacturers, don't put this one in the slowest here and also put it on the slowest here. You might burn your motor. Did you hear me? If you are to use the speed control right here, then all what you have to go set this fan at the highest speed. Remember, everybody knows what I'm talking about? That pull chain, we can put it, fast, medium, and high. So put it on high, and then you control the speed from there. But don't put it in low and control the speed from here, because if you put lower than that, it might burn the voltage. Reducing the voltage too much might burn your equipment. So most of the people, guys, they have the speed control right into that one here, and then you don't put speed control on the wall, but you can put the speed control of the fan on the wall. Any question about that? Fan. So that's basically what this chapter does. Really nice chapter reviewing residential requirement with you, and I think I have a couple of we went through the analysis of that circuit. Always these circuit fans, winter. Yeah, how many of you guys have installed this one? Retrofit. Installed them, Ashley? They're coming really nice. Retrofit fan rated boxes and bars. Anybody installed them? Retrofit. So if I want to go to your house and install a box rated for a fan, if it's a light box, you can put it right there, and sheetrock should be able to handle a light to a certain limit, though, the box. If it's a fan, because of fans, guys, fan boxes, the problem with fan film, my friend, as you know, it's a moving object. Every time you have a moving object, you have rotation, spinning, vibration, and that stresses the box. And if the box is stressed, it will fall. And I'm not going to tell you, if a rotating object falls right on the top of your head, you might not have your head around for long. So the idea is you bring this bar, and I installed a few of them. They're really handy. I hate to depend on them though. And then you squeeze it in, so it tightens all the way in. It goes right through the studs, and then you put your box in here, and you got yourself a fan-rated box, or a light. You can put a light. If you can't put a fan, you can put anything almost. Well, anything as in a light. Any questions about that one? Comes handy. I don't know if you're going to use it in your design. So, fixture box says that one. Okay, on switch medium. Here's the speed control. You have on, off, medium, high. So make sure you set them, or you can have another speed control. A couple of speed controls you can get for light and dimming. Here's what I told you guys that the book is using to analyze the load on the circuit. So they're using, here's how this 15 amp circuit, arc fault circuit interrupter is going to be loaded with. All these are going to be loaded in it. You can see I have receptacles for weatherproof receptacle 1. Where did they get this 120, Phil? There's nothing in the code says 120. A receptacle can take 120. I would use 180. The code says, if you don't know commercial, if you don't know a receptacle, what the receptacle can be loaded is 180. So they threw 120 because residential, I guess. Outdoor bracket luminaires, where did they get this one? From the rating of the luminaires. So now you need to know the equipment. And closed closet, 2 of them, 150. Ceiling fan, they got this for the light and the fan. Add them all up. You got your watts and your volt amps. Get used to this method, guys. What's the difference between watts and volt amps? Power factor. What do we size based on all the time? The volt amps. The volt amps is always higher than the watts. Always. What's the difference? The power factor. Most of them are, as you can see, most of them are the same, except when it went to the motors. The only time it went different, can you guys see that? The motor, because the motor have a power factor. Everything else is incandescent lamps that they're using, it's the same. So we use this more when we go commercial. If you don't want to use the rule of thumb that we use. Okay, height gain, width of the standard walls. Okay, and the rest, guys, is I trust you that you're going to be wiring this one. I hate to say it, guys, if you graduate from Dunwoody without being able to take a circuit like this and wiring it, we just cheated you. We really did. You know, so you're going to find receptacles, bring your circuit in, circuit out, and feed all that light. Now, if I tell you guys to, if I tell you right now to wire this circuit, and I don't give you the layout, that this is based on the layout for the living room, for the master bedroom. If I don't give you the layout, you can wire it in any way, shape, or order you wish to do it. Wire it. So, but you're supposed to take this and go wire it point to point based on the layout in the book. Because right now it's not enough. If you tell me this, which switch do you want me to switch with three-way switches? So why don't you guys, that's part of the homework, please do that one. So we got our, and as I said, in order to do it, really you have to excuse me, I think where they came from the hot, where my hot switched hot, they came from here. And which one? It's just landing on here. Here's my hot, and then they came from here to the light with the hot down to, they energized all these, and then this came and tied to this. This came back and tied to this side, and the neutral, I'm just going to do one of them. The neutral came from this side, tied to this side. Oops, my neutral. Neutral came to this side. If I remember right, came from this side to this side because you need it, and then went with the switch to this side of the circuit. Went to this side of the circuit. The hot came in here, and the switched hot came from this side. And then since the switches need also neutral, you brought the neutral from here, landed right in here, and took it to the light. Here's one side of the circuit, how they wire it. And again, why did I do it this way? You have to look at the layout. And then they continued with the rest of them, with the three-way switches and so forth. Any questions about that? Okay, I'm going to switch quick into the last chapter for the week so we can be on track. As you know, guys, I'm not going to be here next week, so I'm going to, otherwise I wouldn't do that. I'm going to go to chapter 10. Chapter 10, guys, very straightforward. It talks about hallways and bathrooms. Okay, so any question, guys, about master bedroom? Strongly suggest, if you have not wired this and you want to go wire it, come with me, guys. We'll take it down, take it to our lab down there with 14.2 and 14.3 and 14.4. We don't have 14.4, but we'll buy 14.4, and you can wire all this stuff point to point. There's no reason not to be able to wire. No reason. Any question? All of these, guys, that we go over and over again. Okay, this talks about bathrooms and hallways. Quick review bathroom rules. Number one, a 20 amp circuit must be feeding the bathroom receptacle. That circuit is sacred cow, cannot feed anything else except equipment and lights in the bathroom. You can't feed it from lights and equipment in the bathroom. Not based on our design, but based on the code. 20 amp circuit, the bathroom has to have at least one GFCI receptacle or GFCI protector receptacle. The bathroom has to be a light, ceiling mounted light, switched, wall switch ceiling mounted light, or wall switched light, ceiling or wall. What else? Rules in the bathroom. Anybody else? Rules in the bathroom? Can I have 15 receptacles in the bathroom? No problem. Can I feed these 15 receptacles in the bathroom from the same 20 amp circuit? Bring it on. So hallways. If your hallway center measured from the center is 10 feet or more, you need one receptacle. So 10 feet, one receptacle. 1,000 feet, one receptacle. Does it make sense? One receptacle. More. It's not like every 10 feet. Now, of course, you're not going to do that as a designer. 1,000 feet hallway, you're going to put one receptacle in it. You're going to do more than that. But the code is one. It's highly unlikely you're going to encounter a 1,000 feet hallway in a residential. You got to have a big mansion to have that one. Okay, so this is the hallway. We're going to do wiring diagram and all this good stuff. Requirements, hallways, proper lighting requirement, circuit. Let's go directly to the circuit, guys. Luminaires. Okay, definitions. I want to go directly to the definition of the bathroom. It was added to, this is from 2008. They added to the definition of bathroom. Since I need a circuit to the bathroom and the GFC receptacle, the question would be, what the heck is a bathroom? How do you define a bathroom? The code is beautiful in that. A bathroom, guys, you have to have a basin. With that basin, you have to have the following: toilet, tub, or shower. That's how it used to be in 2008. In 2011, they added a bunch of other adjectives. So if you guys go to 2008, definition of a bathroom, they added a couple of other adjectives in it. Excuse me. So it's the same thing: basin with toilet, tub or shower, or urinal, or bidet, or similar plumbing fixtures, or any similar plumbing fixtures. So they added, left it open for imagination. If you have plumbing fixtures with a basin, similar to a shower, a tub, toilet, urinal, and bidet, then this would be a bathroom. Who cares? I need a 20 amp circuit and I need GFCI protector receptacle. We talked about the 20 amp circuit. We talked about the GFCI receptacle. Does it have to be arc full circuit interrupter in the bathroom? No. Arc full circuit interrupter, anything in the bathroom? No. Here's how they did the bathroom. I want you guys, this is probably the most important thing in this circuit. Okay, so I'm going to, the 20 amp circuit, I have a 20 amp branch circuit. 20 amp branch circuit. This is my 20 amp branch circuit. There are two bathrooms. I will remind you guys, there are two bathrooms here. And here's my 20 amp branch circuits. I have two bathrooms side by side, and I'm feeding them from two 20 amp circuits. My question for all of you: could I have fed the two bathrooms from one 20 amp circuit? Could I have fed the two bathrooms from one 20 amp circuit, just the receptacles? Yes. The code allows you to feed the receptacles of multiple bathrooms from one 20 amp circuit. Here we decided to feed it, they decided in the book to feed it from a separate circuit. Okay, so here's the first one. Let's do the second one. The second one, guys, is I have a combo. Look at this. I have a circuit. I will remind you guys that this circuit is an interesting circuit. This circuit is a 20 amp circuit that can feed this device here. Has a heat. Have anybody ever seen them in a hotel where a fan, it has an exhaust fan, a heating fan, a light, and a night light all in one combo? Anybody ever seen them? They're commonly used in bathrooms of hotels, motels, and some residential. The reason for this, guys, if you have this fixture can give you heat, can exhaust the bathroom air, can heat the bathroom, blowing hot air, can exhaust the air out, can give you light, general light and night light. If you have 3 kids like me and you put a general light in the bathroom for the kids to see the bathroom, you can do it. So because of that fixture, what they did, they brought the 20 amp circuit, branch circuit. The reason for this 20 amp branch circuit, guys, is not because it's the reason because it's a big combo. Okay, if it's just a fan and a light, you can get away with a 20 amp with the 15 amp circuit. The same thing they did right here. Can you guys see that? So look at this. I have this one. I have a fan and a light, 2 lights, a fan, exhaust fan, and a heat. right coming out of this combo. We'll show you how it looks like in a second. Any question, guys, about these two different circuits, the red and the green? And the last one is the blue. They brought a circuit here, guys, to feed the light. I think they're feeding this light, this receptacle, and this light from this circuit. A separate circuit for the hallway. Separate circuit for the hallway. That's shared with everything else. Any question, guys, about this? The most important thing really is the red and the green. In this bathroom, we have our exhaust fan in the bathroom. That combo. Any question? Okay. What that one? Got that bathroom fan. Have another circuit A9. It's just feeding the fan combo. All these switches.
If you look at the lower bathroom, is that,
It's a bathroom. It's a basin. Does it have a
no,
basin?
but if you look at how it's wired,
Yeah.
is that not also supplying outlets outside of the bathroom?
You can't supply outlet outside of the bathroom from the bathroom. If it's a bathroom circuit. Yeah, I know. Why are they bringing that cable in between them? Three-way switch for the light.
Well, I guess you can supply the light from somewhere else.
Yes, I think they're bringing the light. Yeah, I think that's what they're doing. They're bringing the light. That circuit number 14 is a lighting circuit. Circuit number 14 is a lighting circuit. So I think that's what they did, if I remember right. So this is circuit number 13 is feeding the light. That's why it's all this mess and light and the receptacle here. So these are fed from lighting. These two lights and the receptacle and the outside light are fed from, and that's okay. Can I feed the light in the bathroom from another lighting circuit somewhere else? The light. It's okay. Any question about that one, guys? The reason why it's a little bit more complicated because they have this mechanical fixture that they need to wire. Okay, a couple of things, guys, about the zone. I'll show you a couple of things. You cannot put the following in a zone of 3 by 8 in the bathroom above the showers and bathtubs. That zone, I'll see that zone. You can't put the following: cord connected equipment, chain and light track, and a suspended fan. Please be aware of that one. These 4 types of lights and fans, you cannot suspend them or put them in the zone, that sacred zone that extend 3 feet off the top and 8 feet above it. Can I put a recessed lighting fixture wet proof? Yes, in that zone, no problem. We'll look at the picture that shows them, guys. The only thing I want to mention here is the 4 types that you cannot put. How about surface mounted? How about surface mounted, guys? Wet rated fixture. Can I put it in that zone? Yes. Wet rated fixture, surface mounted, yes. You can't suspend it though. We talked about hallways. Every 10 feet or more, please bring a receptacle. How do you measure it? Down the center line of the hallway. The most important, turning around corners, no problem, but not passing through doors. And you're going to see a couple of pictures to identify is this a hallway or not. From the center point, don't pass through doors, and you can pass around corners. Equipment, all equipment have to be grounded, guys. So that goes without discussion. Install the wishers located location, part of a listed. Okay, can I put a switch inside the top? Inside the top, can I put a switch? Only if it's part of this inside the top or the shower. Can I put a switch? Just
Switch, sure.
well, you can if it's part of a listed assembly. Can I go drill inside the top and put a switch? No, it has to be listed what not according to the code anyway, has to be listed assembly. If it's listed assembly and there is a switch in it, whatever type of switch listed to work with this equipment, no problem. But you yourself putting a box and doing it, no, 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 no. So keep this in mind. Here's the zone, guys. That sacred cow zone, 3 feet away. This zone, all the way here, that's a sacred zone. You cannot put anything suspended, light or fans into this zone, or plugged in. I can put surface mounted or recessed only if they are wet location rated. Okay, cool. Got this one around the shower, so you've seen it the second time here. Here's what we're talking about. The zone, that sacred cow zone, 3 feet. Don't forget about the 3 feet and the 8 feet. No cross here, okay here, and no cross here. Now, if I decided, Chad Curdy, to put, if the wall was here, guys, here's my wall, and I put a fixture right in here, what location fixture, like this, or a fixture like this, what location? Is this okay? Surface mounted or recessed, what location? It's okay. What location? Surface mounted or recessed. Okay. No suspended. No plugged in. How about if I bring up I land my fixture right in here and plug it in here in a plug? No, no, no. No. Okay, hallways. How to measure the hallways? It's really interesting, Chris, how they do it. Look at this one here. You start from this edge. Okay, now look, we don't go all the way to the other side in the center, and you move. And then if the whole area here, what is it? 3 plus 8? Was it 3 plus 8? Yeah, 3 plus 8. So you take the 3, add it to the 8. That will get you 11 feet. Do I need an outlet? Yes. Where do you put the outlet? Should I put it here? Should I put it here? Where should I put it? Anywhere, as far as a code concerned. Where would you put it? You put it in a wall, the largest wall there. It makes more sense. Can I continue measuring through the door? No. How many outlets per 10 feet you need? One outlet for 10 feet or larger. Not every 10 feet. Do I need a circuit, guys, to feed the hallway? A separate circuit? Or can I feed it from anywhere else except the sacred cows, like the kitchen and the bathroom? Can feed it from anywhere else. Okay, a few pictures, guys, I want to share with you, and then that will be a quick review. Come on, bud. Okay, we talked about this combo. Here's the combo, guys, that we're just talking about. So you brought the circuit. If I want to wire this, just quick here, brought my circuit right in here. Feed this, feed this, feed this, and feed this. And out of this box, you're going to see here's 1, 2, 3, 4. 4 conductors are coming out of this box. Don't forget the neutral now. With a neutral. That'll be interesting. Here's my circuit. Oops, here's my neutral sitting here. So how many conductors do I need to make the system work? 1, 2, 3, 4, 5. So 14, 5. Do they make 14, 5? How are you going to make the system work? Flex. Then they become 6 because you need to pull an equivalent ground conductor in it. You put a flexible metallic conduit. Good solution. And you pull a neutral, a ground, that becomes 6. 3/4 of an inch, flex, or half an inch. Probably half can get you there, 3/4. And so all of them, or you can split them. You can split, well, this is one fixture coming to all of it, so splitting them, you can split them into multiple cables as long as you carry a neutral with every cable. As long as you carry a neutral with every cable. Okay, this fixture, I want to emphasize what it gives you: heat, vent, night light, and light. So right in the same combo, right in the same combo. Couple of lights, guys, that you can use in the bathroom. The way, how are you going to, this is more electrical installation. How are you going to allow the light above the sink? You can either allow a cable like this with enough room so you can pull it and attach it, or you can put a box, right, if you know where that's going to be located. Most of the people give a foot, guys, just a foot, drill the hole in it and allow a foot so you can tie it to your vanity lights. Where do you situate the light design-wise, guys? It's always the man doing the bad things, huh? You usually want to put the light above and in front. Above and in front. You don't want to put them to the side or behind because of shadows, especially those of us who shave every day. It's really nice to be able to see both sides when you're shaving. So that's the proper way of putting it. Is this good? No. Remember, we're designers, so the good application for a bathroom is to put the light above and in front. Not just above and in front. So a few hints here. What else? Junction box with the fixture fans. Here's a couple of examples of fixture fans. Lights in the back and so forth. Bathroom, definition of bathroom. Here's a few definition of bathroom, guys. Basin, toilet, tub, or basin, toilet, or so the only thing, this is, as long as you have a basin, this is a bathroom, even though a door separate them. Look at this one. Here's your bathroom, but this is not a bathroom here. And the reason for this was you do not have just a sink. So you don't have anything else in it. This is a bathroom because this is all seen as one unit. One unit. Here's my bit. This is kind of the sacred cow. Always you're looking to find this and something else, right? You can see that, this and something else. As toilet, tub, shower, so forth.
So
Talked about this one.
The same, just having a toilet.
No, would not be a bathroom. Yeah, you have to have a sink first, and even you don't have to have a toilet. Having a shower and a sink is a bathroom. You don't have to have a toilet, so to speak. So the sink is the main, and the reason, guys, for the sink to main, where do you put the receptacle? On the countertop of a sink, most of the time, within 3 feet, right? Within 3 feet of a countertop of a sink. So that's why the sink rules. Sink has to be there first, and then add one more: a tub, a shower, a toilet, and a couple of other adjectives of mechanical fixtures. We talked about this one, this calculation. You guys, I trust that you can wire this circuit. Okay, here you go. If you guys look at this one, let's do this one together. Which one of these is a bathroom and which one is not? Look at the first one. Oh, okay. We need to find the scale though. Scale is 1/4 to a foot. You have to scale them. So you guys will do that one. I just want to show you where to measure the distance. You scale them. You're going to measure from the center to center here. You're going to measure from center to center here as you measure from here to here, and again from here to here. And what's the last one? The last one required, okay, scale. And oh yeah, these two, it's to the bottom, from here to here. So that's, you measure it, you scale it. They're giving you guys the scale. You have one of these scales. You should use one of these, and then you should be able, let's just, I'm going to do number 8 and use the 3/4 inch. 3/4 inch number 8. Based on 3/4 inch number 8, I have 0 right in here. They're 8 foot. 8 foot. Do I need a receptacle for the first one? They're 8 feet. So based on the scales, this one is 8 feet. No receptacle required. Is it a good idea to put a receptacle if it's my house? Yes. If it's your house and I'm wiring it to code, no. I'm bidding it to get the job, no. Does that make sense, guys? And you can do the rest. This is in the exercise that you have. But look how they measure it. I just want to mention the measurement. If you want a scale, if you don't have scale, and you need to have one, guys, when we do the takeoff. It comes very handy. I know there's the wheel and a bunch of other adjectives, but you really need to know how to use that one. I do it over the, if you don't know, I usually do it over the estimation when we do estimation. Okay, so that's basically it, my friends. Any question? I really strongly suggest, and you guys do the wiring, please, at the end. Here's what happened. Here's what happened, Chris. When we reach the industrial and the commercial, we start doing wiring and takeoff, and people still don't understand the three-way switches or occupancy sensor, how occupancy sensor works. Understanding the wiring is a must. You don't have to know every single material, but you have to know if you have a receptacle, you need at least two conductors, a hot and neutral, and by code you have to have a ground, right? So that's always hot and neutral, and the ground always comes without discussion with everything. If you need a switch, you need at least two conductors. One bring the power to the switch, and one take the power out of the switch after it controls it. And now by code you need a neutral in 2011. So you need three, every single switch have to have three conductors now. A neutral, a hot, and a switch type. Plus, of course, the ground. So these basic things must know. Must know. Any question, guys? That will conclude our plan for this week. What I'm going to do tomorrow, guys, I'm going to go over chapter 6. And let me just see here. Where am I?